Here we are, ready to wrap up Chapter 7. We have our last section in Chapter 7, which is 7-7. And it's about write and apply exponential power function. As I know all of you have been waiting for, here he is, our lumberjack. This is the guy cutting down the logs. That's what you guys are going to be on this test coming up here. Cutting down logs, just like Paul Bunyan and his trusty steed, Babe. What we have here is we're trying to solve these equations, and we're trying to write exponential functions that pass through certain points, and that's what we're going to wrap everything up with. Probably the toughest stuff we're going to do. We're going to really need you to focus, listen in, and every once in a while you're going to need to pause the video just to gather your thoughts, I'm sure. As we look at this here, we know that the form that we're looking for is y equals ab to the x, and we want something in exponential form like that goes through these points, 110 and 480. 110 and 480. That means on the first one, if I substitute 10 in for y and 1 in for x, and on the second one, if I substitute 80 in for y and 4 in for x, I now have two equations and two missing variables, which means I can solve this. So anytime I have two equations and two missing variables, it puts me in a position where I can solve the equation. So if I take a look at it and I try to get it to a similar situation, it says solve a in the first equation to obtain whatever you could substitute for a. So I'm going to divide 10 by b, and I'm going to get a equals 10 over b. Okay, so we know that to be true. So in the second equation, instead of a, I can write 10 over b. And I have b to the fourth on the top and b to the first on the bottom, so I end up with 10b cubed. All right, so 80 equals 10b cubed. When I divide by 10, I get 8 on one side. Divide each side by 10, it says to do right here. And I get b cubed. Well, what number cubed equals 8? Well, b is 2. So if b is 2, I go back into one of my original statements, like this one even, and I do 10 divided by 2, and I get a equals 5. So I find... and that doesn't wrap it up for me. I have to finish up this equation. If b is 2 and a is 5, then my original equation was y equals 5 times 2 to the x. Now somebody out there, just in their brain, just for a split second, said, "Ooh, it's y equals 10 to the x." You cannot multiply 5 times 2 because you have to do exponents first here. See, 5 is to the first power. You got to multiply the exponents first. So you have to leave it as y equals 5 times 2 to the x. And that would be the answer for that first example. You guys try to do that same thing on checkpoint 1. Take a moment, say goodbye to Paul Bunyan, and you can do that same thing on checkpoint 1. I'd like to see all of your work on that as well, please. Goodbye, Paul Bunyan. All right, welcome back. I hope you went through and did all of that same process. And if you did it, and you did it correctly, you got y equals 2 times 4 to the x. If you did it and you did it correctly, you started with something like 8 equals ab to the 1, and 32 equals ab to the 2. And you solved for a, so you divided by b, put it in here, and you were able to solve it for your a and your b. And you got to this point. Hopefully you have all the rest of the work there. Hopefully you're paying attention because you got burned yesterday. You know you're going to show your work today, which is great. Let's take a look at example 2 here. On example 2, we have, I'm gonna show a little bit more of this. Hold on just a minute. I'm gonna go to my, if I could show just a little bit more of example 2. That's just about enough of it. the table here, we have a whole entire table of points. Okay, you have T and you have A. And it says the table shows the amount A in a savings account T years after the account is opened. Draw a scatter plot of the data pairs T and A. T is your X number and A is your Y number, or the natural log of A would be your Y number. Is an exponential model a good fit for the original data TA? Find the exponential model. So first of all, we're going to use our calculator to create a table of data points. So we need to go grab our calculator real quick and follow along on these steps. This is going to take a little bit of time, but you just follow along. So we're going to put these data points into our calculator. So to do that, we're going to go to our lists under stats. We're going to do second, and or maybe we could go to stat and just edit these lists. That's what we'll do. That'd be easier. So we're going to go to list 1, and in list 1 we're going to put 0, 0, enter. There we go. 0, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7. So we have all those points. We go over to list 2, and in list 2 we got to put 210 in there, and 255, and 310. And I know some of you guys are already saying, Mr. Emiot, you're not doing it the right way, you're not putting the right things in there. Well, follow along with me, except for that one. Don't follow that one. 370. I don't know why that's not working. 377. There we go. Enter 459. I'm going to show you a little bit of a shortcut if you can bear with me. So 557, 677, and 822. And what your notes had said was take the natural log of each of those things. What I can do in list 3 over here, so what I'll do is I'm going to go over to list 3. I'm going to go up top, and I'm going to say list 3. I'm going to say list 3 is going to be equal to the natural log of list 2. And if I go under stat, no, I don't want to get it there. I want to get it, go back to edit. If I go to list 3 and I say I want list 3 to equal the natural log of list 2. You see list 2 is right here on the number 2. So I'm going to do second list 2. And what it will do is it will take the natural log of all those points from me, so I don't have to do it individually. And that might have saved me a few minutes time. Okay? So I have list 1, and I have list 2, and I have list 3 here. And now we want to plot the new points to a line. So an exponential model should be a good fit for this original. Let's see if it makes a line. So what we're going to do is we're going to go to second, stat plot. Now I know you haven't ever used stat plot up to this point. We're going to go to stat plot, and I'm going to go enter right here. I'm going to turn this on, and I want to compare list 1 not to list 2, but remember to list 3. And there we go, list 3. And a scatter plot, that's what this would be. That would be just fine. Use these for marks. That's good. And let's just hit graph and see what we got. Oh, look. Boy, that makes a pretty good line. Because that makes a pretty good line, that's a pretty good model. And that's one way to go about things. Okay? So that's just kind of filling us in on that whole concept. Now, to find an exponential model, A equals AB to the T, let's reduce this a minute and get back to our notes. To find an exponential model, A equals AB to the T, choose 2 of the points on the line, such as 1. Now remember what 1 was, and we got to go back to our calculator because Mr. Emiot didn't leave that up. Stat, edit, okay. Such as 1, 5.54. 5. Oh, that's a nice looking 5. 5.4, And you probably want a little further down. So 6 is a good one to choose. And we had 6.52. 6.52. So 6.52. So we can go with those. And if we follow this pattern, the natural log of A minus 5.54 so we can solve for A in this situation. Natural log of A minus 5.54 equals 0.196 0.196 times t minus 1. And so if I add that to the other side, I get 0.196, not a very good 9 there, times t minus 1 plus 5.54. All right. So what this whole thing does for me is it starts allowing me to solve for A. Now, because we have this model here, we can put together the natural log of this really means e to all of this stuff. All right, e to each of these things as they're put together. So if I look at it kind of like this, e to the 0.196 to this whole thing right here. If I just put parentheses around it and just say, I'm going to send e to all of that stuff. All right. The one thing that it will result in is e the one thing it'll result in is e to all of this stuff here. And if you take that 0.196 times t minus 1, okay, and then you add 5.54 to it, it ends up being this whole, thing, but it's 0.196 t minus 0.196 plus this, so that ends up being 5.344. Now, what happens is when e is 2, this is to the t, and then this is a plus sign right here. And when e is 2 all this stuff, you can, because it's plus, it kind of breaks down to be e to the 0.196 t, okay, and then e times e to the 5.344. All right, this ends up being a number, and that number actually ends up being 209. Okay, this e to this stuff this part of it ends up being a number to the t power, and the number that it ends up being is 1.22. Now, that is an incredible amount of work, and I want to show you a trick here so that you can not have to do all this work. But you're just going to use your calculator to do an exponential regression on the data point. So I wanted to show it to you. I wanted to show you how you could do it by hand. I don't imagine many of you are going to do it by hand once I show you this new method. So what you're going to do on your calculator is you're going to go to your stats, and because you have those lists, L1 and L2, you're going to calculate an exponential regression. All right? And you want an exponential regression with list 1, comma, not list 3, but list 2. You really don't have to do all the linear stuff that we did in the beginning, or the natural log stuff, that we did in the beginning. You're just going to do an exponential regression on these things, and guess what you get for an answer? 209 and 1.22. So it's that fast on your calculator. rewind that, watch that again. That's going to make your life easier to do it on your calculator instead of by hand. But I did want to show you how to do it by hand, just for those of you who are maybe curious, or maybe you don't have a calculator yet and you need to do it by hand. God, I hope not. So, all right, let's take a look at what we have next here. Example 3. In example 3, it says write a power function of y equals ax to the b, whose graph passes through this point and this point. I know some of you smart ones right now are saying, ooh, Mr. Emion, I think I saw a power function on the graphing calculator. Can I just do it on the graphing calculator? Yes, you can, but I'm going to show you how to do it by hand once again, because I want to make sure that we're all on board. A times 2 to the b, and I don't know what a or b is, and 10 equals a times 6 to the b, and I don't know what a and b is. I can solve this for one of the variables so that I can substitute back into the other. Whatever one I choose is whichever one I choose. I mean, there's probably a ton of different ways to do it, but I might go with the way we did earlier, so that a is just simply going to be 4 over 2 to the b. That might probably be the best way to do it. So then I'm going to substitute that right in here, and I'm going to get on the top 4 times 6 to the b over on the bottom 2 to the b. All right, and because both of those are to the b power, that gives me an advantage. You see, if I have 4 times, and if I break this fraction up to be 4 over 1 times 6 to the b over 2 to the b, because they're both to the same power, that becomes 4 times 3 to the b. All right, and so 10 equals 4 times 3 to the b. And if I divide each side by 4, then I get 2.5 equals 3 to the b power. And if I go along with my change of base or all the stuff that I do to figure that out, I can find my answer. What I would probably do, like I always do, is I would take the log of 2.5, and I'd make that equal the log of 3b, or 3 to the b. I drop my b down in the front here, and I divide both sides by the log of 3. So on my calculator, I do the log of 2.5, the log of 2.5 divided by the log of, divided by the log of 3, and I'd get 0.189 or whatever that is. And that would end up being my answer for B, 0.189. Okay. Once I found what B was, I'd plug that in, and when I plug that back in, I'd be able to find my A answer. And looks like I may have made a little bit of an error here. I should have been doing, when I drop this over, let's see, if I took the log of both sides, I'd have the log of 2.5 divided by the log of 3. Let's make sure I got this right here. The log of 2.5 divided by the log of 3 is 1.89. That's good. That's perfect. That's what I want. That sounds great. And if I plug that back into one of my originals, so like 2 to the 0.189, 4 divided by that. So if let's go do that real quick. 2 to that power, and I can do second answer, which will give me that exact power, enter. And then if I do 4 divided by that answer, second answer, enter, should give me my A number, which I'm getting at 3.5, and I'm hoping that's right. It somehow seems to be right. So y equals A is 3.5, B is 0.189 to the x power. I'm sorry for that terrible handwriting again. All right, so as I had a moment to think about this or look at it a little closer, I noticed that I don't know why I was writing 1.89 here, which messed up all of this stuff, and I apologize. It really should have been 0.834 when I do that the correct way. 0.83 or 0.834 is what my calculator said, and you guys all saw it, and for some reason I didn't write it the right way. 0.83, that's what I got for B, and then that would have resulted in 2.25 for A. Now, real quick, one time on my calculator, power regression for 2, 4, 6, 10. How would I do that, Mr. Amiat? Well, if you go into your stat plot and you do edit, and let's say over here in list 4 and 5, we do 2, enter, and 6, enter. And we go over here, 2, 4, enter, and 6, 10, enter. And if we do a stat, calculate power regression, enter, and we do a power regression over, I think it was list 5 and 6. Where's it? We're in 5 and 6 there. 4 and 5. So if we do a power regression, calculate, let's get out of this. We want list 4 and comma list 5. And do a power regression for list 4 and list 5. And you got, there's your A, there's your B. A lot quicker than Mr. Amiat did it. It took me way too long. But that's how you would do it if you could do it by your calculator and not have to do it by hand. That's another option. All right, you guys go ahead and take a look at those checkpoints. Hopefully you have better luck than I did. Take a few minutes, get those done. All right, welcome back. Let's take a look and see what you should have had for answers there. Hopefully you found a way to do them. On checkpoint, on that first checkpoint there, you should have had y equals 17.55 and then times 0.913 to the x. And on the other one, you should have had y equals 2.42 x to the 1.09. Hopefully you're able to do those. We'll certainly, I'm sure, answer some questions about that tomorrow because I probably could have done a better job with that stuff. All right, let's take a look at example 4 and then your final checkpoint. In example 4 here, the table gives an approximate V for spheres. Now we're looking to find a power model here, and as I'm going through trying to find this power model, remember we have that excellent tool on our calculator. Probably a great way to do this problem is just type all this stuff in. You could do a natural log of R and a natural log of V, and that's going to help you to find that power model. But you know, probably what I would do is that same method we did earlier, type this into your list and get a power model. So let's do that one more time. Here we go, power model. We're going to go to our calculators and pull those out. Everybody follow along with me. If you could edit your list right along with me, that would be great. We're going to clear out list 1, and we're going to clear out list 2 because those are your default lists on your calculator. We're going to go 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. And go to list 2, and in list 2 we have 4.189 and 33.51. And if you mess up even one of these numbers as you're doing it, it's going to cost you. So you really don't want to mess those numbers up. You got to make sure you type them in and you're accurate. And if you find any mistakes or anything that looks odd when you're done, well, go back and take a look at them. Make double check. That's the first place I would look. I don't know how many times as a teacher I have found students not without the right stuff on there. So what's wrong with this? Mine doesn't look like yours. So we're trying to find a power regression for list 1 and list 2. So we're going to do stat, calculate, down to power regression. And it automatically defaults to list 1 and 2. So if you put things in list 1 and list 2, it will automatically go ahead and give you your power regression for that. And this is exactly what you would have found if you'd done it by hand. So we're going to come over here, and we're going to type that in right here, 4.19 and x to the third power, because that looks like a 3 to me. It doesn't look like a 3 to you. All right, so that makes you, that's going to save you a lot of time, that little trick there. And you guys go ahead and do checkpoint number 4. And I'll throw that answer up there and see if you guys can come up with checkpoint number 4 all on your own. So go ahead and pause it. All right, here's what you should get. 7.92 x to the negative 0.769. Don't need to show you work on that one. Thanks, folks. Sorry for the long video. Have a good day.